Just wanted to show a quick demo of this thing that I'm working on. I think it's pretty cool. So for people who haven't seen this before, this is Massdriver. So it's an infrastructure automation platform that lets you develop Terraform, Helm, OpenTofu, etc. modules, publish them into a central repository, and then your developers for self-service, instead of learning your ops team's tool chain, they can just diagram what they want from the cloud, and we pull all these infrastructure as code modules and do all of the provisioning behind the scenes for them. And so one of the things that we've kind of always believed in is making not just self-service on day one, day zero easy, but self-service on day two easy, and making the maintenance burden easier. And so behind the scenes, what actually happens in Massdriver is, as you kind of diagram this stuff out, we essentially build these ephemeral CI/CD pipelines that run all of your provisioning. And so in any given box on the screen here, whether it's this VPC or whether it's a Kubernetes cluster, whether it's a Helm chart, you can actually have multiple IAC tools packed together in there. So I can have, let's say, a Helm chart, I run on AWS, I could have a Terraform layer inside of that Helm chart that does all my Postgres authentication, all my firewall rules, etc. And then a Helm chart that executes is able to pull that information in and assign like the role from the Terraform into the Helm, right? And so one of the things that's key with Massdriver is all of your infrastructure as code is a first-class citizen in our API. So you can see here, this is just me hitting our sandbox organization. I got a whole bunch of different Terraform modules, Helm modules, OpenTofu modules, etc. You can see right here, I've got this Aurora Postgres one that I had on this canvas here. And so one of the things that we've been trying to do is make it not just easier for developers to manage infrastructure, but operators as well, right? And so when you think about self-service, and I start allowing developers to do whatever they need to do, you know, with Massdriver, I can give them pre-approved infrastructure. I've got all my compliance and infrastructure tooling packaged into one thing. So like when we make this Aurora Postgres here, it's not just Terraform or OpenTofu, it's actually Checkov and OpenTofu. And so a developer says, I want Postgres, and the entire pipeline of your infrastructure tooling gets deployed when they drag that onto the campus, right? So it's literally forcing them into all of your compliance tooling, making sure they don't have to copy walls of YAML to do everything. Now, the other thing that we've seen that kind of sucks about managing infrastructure is like day two, I want to make a change to a module, like maybe this AWS Aurora module here, right? And I don't know who's using it. That's a problem, right? And you know, one of the things that we've always kind of shit on is GitOps, right? And it's like, yeah, it's great for applications, cool, you guys use Argo CD, but like at the end of the day, like that's fine. Most of what we do as operators and developers is read. We read, right? And so using Git as your read database to understand what's going on with your infrastructure is borderline stupid. Sorry, that's just how I feel about it. Like it's great to be able to say, oh, like this is what I think prod is like, right? But the reality is, if I need to find every single version of a module that is using my Postgres module, right? So I've got a shared Postgres module. I've got 1,000 root modules out there for every developer that's deployed some Terraform. How do I find that, right? Well, I have to get every single repo that I have. I have to grep it. I have to kind of understand their code base. I have to find all the main.tfs, etc. Find the ones that reference my module. And get the developers to bump it a version if I want to change something, and open a PR and see if the plan works and do that for every single one. That kind of sucks. So one of the things I've been working on in Massdriver is this idea of draft publishing. And so the way that this works is I'm gonna hop over here. So I've got my Mass CLI tool. So we call this concept of infrastructure as code and policies code, we call this a bundle. So again, this can be any policy tooling, any IAC tooling. The way it works under the hood for operators, DevOps, platform engineering folks, it's literally just a Docker image. So you can push Docker images into Massdriver and say, hey, this is how we run infrastructure. This is how we run Terraform. It is OPA to analyze the plan. It is some Terraform, and then it's Checkov after the fact. It doesn't really matter to us. But any tooling can go inside this thing. And so what I can do here is I can publish a draft version of this bundle. And so one of the things that we've been trying to do is make the maintenance of your infrastructure as code easier. And when we think about this, like I've seen so many teams that they use git SHAs, they use main as like the reference for the modules, or maybe they're pinning them, right? And honestly, like all that sucks. Like Semver is great, yay, but like it'd be better just not have to think about it. And so what a draft publish does is it takes this bundle concept you have. So I'm sitting in this directory now of all this AWS Aurora Terraform code, And what I'm going to do is I'm going to draft publish it. And what it's going to do is it's going to package up that infrastructure as code. It's going to push it into Massdriver as a draft. It's going to find every single invocation of that module. So every place that Postgres module is used, and it's going to run a check to make sure that the Terraform is valid. It's going to check that all of the parameters and this concept we have called connections that lets you connect things on the graph are valid. It will run whatever your policy tooling is on the plans. You can see Checkov is running here in each of these environments. And then finally, it will run the Terraform plan and show you what the different changes look like, right? And so what's cool about this now is I can see that there are there's 6 different teams or developers that are using this module. And if I were to push this as is right now, I can see that 5 of these have valid Terraform, valid parameters. Their Checkov is passing, right? And I can see that there is 2 of them's got a couple of scary changes, or 3 of them's got a couple of scary changes. I can see some deletes in there, right? And so instead of me writing some inane, anemic Terraform test that's like, oh yes, you can set the region to US West 2. This is actually testing that the changes that you're making aren't going to break prod. And in this case, I can see that I've got a change that in 3 of my environments is going to be problematic. And so now I can go and find those modules and figure out what about these modules is different. You actually see I didn't meant to comment this part out, but there he goes. We're doing a little bit of AI thingamajiggy here to actually analyze all of the current deployments that you have and compare it. Older code, the new code that you've just drafted, and their configuration to kind of ID like what in your code is causing this to either fail a checkoff policy or cause a deletion or cause an addition in one of these cases. So just kind of stuff that we're thinking about, working on. I think this is super cool. This is way longer than I intended it to be. If you actually watched all 7 minutes of this, you are, as my toddler says, cuckoo bananas, but thank you.